There is a light older than every star you have ever seen, older than every star that has ever existed, and it is, right now, passing through your body. You can't see it, your skin doesn't feel it, but it is here. Billions of these ancient photons strike every inch of you, every second of every day, and have done so for your entire life. They are the oldest things in the universe. They were born before the first star ever ignited, before the first atom of carbon, the first hint of oxygen, the first molecule of water. They predate gravity wells, planet formation, and chemistry as we would recognize it. And we have spent the last 70 years slowly learning to read them. For decades, we knew this ancient light existed. We could measure it. We could map it. What we could not do was see what came right after it. The era when the first stars finally ignited. The era when the cosmos went from darkness to fire. That window of time, hundreds of millions of years long, sat just out of reach. Until 2022. Until James Webb opened its mirror. What it found there has broken the universe we thought we understood. And the deeper Webb looks, the more it confirms something unsettling. We are not the observers in this story. The light is. It has been waiting. To understand what Webb is doing, you have to understand the period it is finally letting us see. Astronomers call it the Dark Ages. About 380,000 years after the Big Bang, the entire universe became transparent. Before that moment, the cosmos was a fog of charged particles, hot enough that light could not travel in a straight line. It bounced and scattered and went nowhere. Then the temperature dropped. The first neutral atoms formed, and in a single, universe-wide instant, the fog lifted. Every photon that had been trapped for nearly 400,000 years was suddenly free to move. That light is what we now call the cosmic microwave background. It is, in the most literal sense, the first thing that ever happened in a universe you would recognize. And it is still here. Stretched out by 13.8 billion years of expansion, the original glow has cooled to a whisper, just a few degrees above the coldest temperature physically possible. But the photons themselves are the same ones. The same individual particles of light that escaped that fog are still flowing through space, through Earth, through your living room. You think of light as something you see, something a lamp produces, or the sun, or a screen. But the room you are sitting in right now is full of light older than the sun by more than 9 billion years. Lift your hand for a moment. Trillions of those ancient photons are striking your palm every single second, and you do not feel a thing. Your TV screen, the wall behind it, the floor under your feet, all of it is being constantly bombarded by the oldest things in existence. This is the light Webb is studying. Not directly. The background glow is too cold and too uniform for its mirrors. But what came after it? The slow ignition that the background gave way to. After the universe became transparent, something strange happened. For roughly 100 million years, nothing did. No stars, no galaxies, no visible structure of any kind. The universe was a soup of hydrogen and helium, slowly cooling, slowly collapsing under its own gravity, but producing no new light at all. Astronomers call this the Dark Ages because there was, in a literal sense, almost nothing to see. A camera placed at that moment would have shown you blackness. Not the blackness of a moonless night in Montana, where stars still puncture the sky. The blackness of a sealed basement with no light source. This period lasted somewhere between 100 and 200 million years. And until recently, we had no way to look at it. The only light from that era was the slow, faint hum of cold hydrogen gas, far too dim for any telescope ever built. Then, somewhere in that darkness, the first stars switched on. We call them Population 3. They were nothing like the Sun. With no carbon or oxygen or any heavier element to slow them down, these first stars grew enormous. Some of them carried hundreds of times the mass of our Sun. They burned blinding hot, blue and fast. The largest of them lived only 1 million years before exploding into the first supernovae the universe had ever produced. Those explosions forged the first carbon, the first iron, the first oxygen. They built the building blocks of every later star, every later planet, every later you. Nobody has ever seen a Population 3 star, not directly. We have models, simulations, and indirect evidence, but the moment of first ignition has remained, for a long time, theoretical. That brings us to Webb. Of all the things the telescope was designed to do, the most ambitious was this. Look back to the moment when the universe lit up. Catch the era of the first stars in the act. In its first few years of operation, Webb has already found galaxies older than anything previously detected. The current record holder is a galaxy designated JADES-GS-Z14-0. It existed when the universe was only about 290 million years old. Light from it has been traveling toward us for over 13.5 billion years. To get a sense of that distance, picture a single photon leaving that galaxy at the speed of light, about 186,000 miles per second. By the time it reaches Webb's mirror, our Sun has not even been born yet. The Earth doesn't exist. Every continent, every ocean, every dinosaur, every human being who has ever lived has come and gone in the time that single photon was in flight. And there are now dozens of these, not one, dozens. Webb is finding ancient galaxies the way you find seashells on a beach. Reach down, pick one up, look, there's another, look again, there's another. Each one is a window into an era we thought we would never see. Here is the problem, and it is a problem that astronomers are still trying to make sense of. Many of these galaxies are too big. According to the best models of how galaxies form, the universe at 300 million years of age should have contained only the smallest, dimmest, simplest galaxies. Tiny clumps of gas just starting to organize themselves into recognizable shapes. Webb has found galaxies from that era that look, by every measurable property, fully formed. They are large. They contain stars that appear to have been burning for hundreds of millions of years already. Some of them seem to have already produced the heavier elements that take generations of stellar death to forge. This is not supposed to happen this fast. The leading model of cosmology, the one that has worked beautifully for 60 years, says that galaxy formation is slow. Gas collapses. Stars form. Stars die and pollute the gas with heavier elements. The next generation of stars takes that pollution and forms planets. This process should take billions of years to produce something with the size and complexity of, for example, our Milky Way. Webb is showing us Milky Way ancestors at less than 5% of the universe's current age. More than one astronomer working on Webb data has described the same reaction to seeing one of these early galaxies for the first time. You see the analysis. You assume there is an error in the pipeline. You run the numbers again, then again. The galaxy is real. It is just impossibly mature. The bigger surprise, the one nobody saw coming, are the objects we now call the little red dots. When Webb began surveying the deep sky, astronomers expected to find faint smudges, distant galaxies blurred by distance. What they actually found, in image after image, were sharp red points. Bright, compact, intensely red. Not blurred smudges, pinpoints. Hundreds of them, sometimes thousands per field of view. For a while, nobody was sure what these objects were. Some thought they were unusually bright early galaxies. Others suspected they were quasars, the engine of an actively feeding supermassive black hole. The truth, it now appears, is more disturbing than either. The little red dots seem to be galaxies that, at the universe's very earliest age, already contained supermassive black holes at their cores. Holes weighing millions of times the mass of our Sun. And they had them within a few 100 million years of the Big Bang. This is, by every model we have, impossible. A black hole that massive should take billions of years to form. You need a star to die. That dead star becomes a small black hole. The black hole feeds, it grows. Over billions of years, it merges with other black holes. It builds up. Eventually, after enough time, it becomes a giant. Webb is finding giants that had no time to grow. What this means is one of two things. Either our model of how black holes form is wrong, completely wrong, in a way we have never imagined, or these early black holes formed by a process we haven't yet discovered. A process that took hundreds of millions of years instead of billions. A shortcut, hiding in the physics of the early universe that we have somehow missed for a century. Both options are equally unsettling. Both rewrite the rules. The impossible galaxies and the little red dots, as strange as they are still not the part of this story that should haunt you. The part that should haunt you is what the light itself has done to get here. Every photon Webb is collecting from those galaxies has been in transit for 13.5 billion years. During every second of that flight, it has been passing through space. Through empty regions and through gas clouds. Through the cores of galaxies that formed long after it set out and out the other side. Through the void between superclusters. Through the entire structure of the universe. And by the time it arrives at Webb's mirror, that light carries a record. Not just of the galaxy that sent it, a record of everything it touched along the way. The amount of hydrogen between us and the source, the density of dark matter through the regions it crossed, the expansion rate of the universe at every moment of its flight. Every photon is a letter from a place we cannot visit, addressed to a time it could not have known would exist. Now consider something else. The light from those galaxies is not stopping at Webb. The mirror catches a small fraction of the photons. The rest keep going. They pass through the telescope, through Earth, through the empty space behind us, and out into the dark on the other side. If there is anything out there, anything looking back, the same light is now reaching them too. If a civilization on the far side of the Milky Way is studying the early universe, they are reading the same letter we are, the same photons. They have arrived at our solar system, kept going, and arrived at theirs. The light has been everywhere. It has watched the universe assemble itself, watched the first stars die, watched the heavier elements form, watched the gas collapse into the first generations of galaxies, watched the Milky Way's earliest ancestors come together, watched our sun ignite, watched Earth cool, watched life begin, watched a species build a telescope to read the message. And then it has continued on. It is not watching us, not in any conscious sense, but it has carried a witness account from a time when nothing in our world existed yet, all the way to a time when we have built a machine capable of receiving it. That coincidence is not nothing. That coincidence is the strangest thing about astronomy. Now come back to your own body, to the room you're in, to this moment. The afterglow of the universe's first moment of transparency surrounds you on all sides. Every cubic inch of air in your home contains several thousand of those photons at any given instant. An average American living room is holding tens of billions of them. And every second, quadrillions of them cross your body from one side to the other. You feel none of it. You will never feel them. They are too low in energy. Your senses cannot register them. But they are there. They have been there your entire life. They were there when your great-grandparents were children. They were there when the pyramids were built. They were there when the first humans walked upright. They were there before any human existed, before any mammal existed, before complex life existed, before life of any kind existed anywhere on Earth. They are older than every story ever told, and every breath ever drawn, and every shadow ever cast. And Webb is finally pushing into the era just after they formed, the era nobody had ever seen. Here is what the data, taken together, seems to be telling us. The universe lit up faster than we thought possible. The first stars formed earlier and burned hotter than the models predicted. The first black holes grew faster than physics, as we currently understand it, allows. The first galaxies assembled themselves with a speed that our simulations cannot reproduce, no matter how we tune the parameters. For decades, we had a clean story of how the universe became what it is. Smooth, predictable, gradual. Webb is showing us, year after year, that the early universe was anything but smooth and gradual. Something was driving the formation of structure at a pace that surprises every astronomer who looks at the data. What that something is, nobody yet knows. And honestly, this is the part of the story that still gets to me. We built the most sophisticated optical instrument in human history, specifically to confirm what we thought we knew about the early universe. We expected the data to fill in gaps in a familiar picture. Instead, it has spent the last several years systematically demolishing that picture. And the more it looks, the worse the demolition gets. The galaxies should be smaller. They are not. The black holes should be tinier. They are not. The structures should be simpler. They are not. Somewhere in the first few 100 million years after the Big Bang, the universe did something we cannot explain. It built up in a hurry. And the light from that hurry is still arriving at our mirrors today, carrying the evidence of an early universe that nobody alive has ever fully understood. There are competing explanations now lining up to fight over the data. Some researchers think dark matter behaved differently in the early universe than it does now. Others propose that the first generation of stars must have been even more massive than current models suggest, producing enormous bursts of structure formation. A few have even floated the idea that we are misinterpreting the light itself, that the distance measurements to these early galaxies are off, that the universe is not actually as old as we think. None of these explanations is settled. None is fully satisfying. The early universe, as Webb is revealing it to us, is a place that fits no current theory cleanly. But the light keeps coming. That is the part that should leave you with a kind of vertigo. Whatever the explanation turns out to be, the light does not care. It has already arrived. It has already passed through us. It is on its way out the other side, carrying the same message it carried in. And in a few 100 million more years, it will arrive somewhere else, at some other instrument on some other world, if such a thing exists. And those observers will see what we see. The same impossible galaxies, the same impossible black holes, the same evidence that the universe started up faster and harder than the math should allow. We are not the audience here. We are not the ones for whom the show is being performed. The universe was producing light long before our species existed, and will continue producing it long after we are gone. We have, for the briefest sliver of the universe's lifetime, intercepted a tiny fraction of that output. We have read a few letters out of a library so vast that we will never finish it. Every image Webb sends back is a postcard from before us, addressed to nobody in particular, that we happen to catch in transit. Every postcard carries the same impossible signature. Something happened early, something we cannot yet explain. The telescope was built to confirm our understanding of the early universe. Instead, it has spent its first years quietly showing us how small that understanding really was. The light has been here longer than the planet. It has been here longer than the sun. It will be here longer than us. And for the smallest moment in its long, long flight, we are the species lucky enough, or strange enough, to have noticed it. To have built mirrors. To have read its language. To have looked into the oldest darkness our universe has ever known. And to have seen something staring back. What we saw is impossible. What we saw rewrites what we thought we knew. What we saw is still arriving. And that's it for this video. Thanks for watching, and I'll see you in the next one.